Thank you. My slides are online, as always, talks.php.net, Twitter @Rasmus. So, I'm here because I'm old. I've been around for a very, very long time. Since computers looked like this was my first computer. 1K of memory by default. This big box at the back was a 16K memory expansion I got for it. If you think about that a little bit, 1K of memory, right? 1024 bytes, that's it. That's all there was in it, right? Your watches have way more memory than that. So yeah, that's how old I am. I had computers like this, ended up buying a Hayes modem to get online in the 80s. The internet to me, when I was some of your ages, was this. Watching Z modem download very, very, very slowly. In the 90s, we still didn't have the web. When I went to university, there was no web. The closest we had, the internet was there. Most universities were connected. The closest we had to the web was called Gopher, which looked like this. It was text only. It was mainly used in academic papers. So you read a paper at the bottom, there were some references to other papers. You could scroll down and you can then click on those references. So the idea of hyperlinking to other documents was there before the web browser and before HTML. But nobody outside of academic circles really used Gopher. There were some government sites as well, and a little bit, but regular people had no idea what it was. It wasn't until 1993 that the world changed with Mosaic, the first graphical browser. I was working in California for a Brazilian company at the time, actually. And as soon as I saw this, everyone who saw this, who was working anywhere near the industry, knew that the world was going to change. And I started building websites and quit my job, moved to Toronto to do basically web consulting. And I started writing code that looked like this. So these are CGI scripts written in C, because we didn't have any frameworks or tools or anything in '93. So big ugly C code with HTML embedded in it, and if you wanted to change any little detail of the HTML, you needed to recompile and redeploy. And yes, this was a CGI script, so every single execution had to fork and exec a CGI process to execute to show the dynamic page. That just wasn't a feasible way of building websites quickly. Most of the world moved on to CGI PM, which was a Perl module that basically did the same thing. Instead of writing your HTML inside a C program, you now put this weird Perl wrapper around it. I really didn't like this. I was a big Perl fan. I did everything in Perl, but I wanted my HTML to look like HTML. I wanted to separate the business logic from the display logic, and this mushed it all together. Now, one of the big criticisms of PHP over the years is that PHP mushes it all together. That was definitely not my intent. The whole point of PHP to me was to separate the business logic and the display logic. So I wanted my solutions to look something more like this, right? This output exactly the same thing as this does. But to me, this was cleaner because I could hand this off to designers and to HTML folks and say, make this look nice. I'll handle the back-end stuff, and I'll give you some magical tags that you can put in the HTML where you need it. And a little bit of display logic, maybe some conditionals, just enough so that you can put the right tags in the right places based on whatever display logic you need to execute. So that was my whole approach to PHP. This was basically a C API for the web, was the way I was trying to pitch it. And I gave a bunch of examples of how you could implement guest books and log stats and all kinds of interesting things at the time. And my examples were basically these magical tags that were available in this templating system. And the templating system had a little bit of display logic built in. And I tried to convince people that you should write your business logic in C and use my templating system, my C API, that made it very, very easy to sort of forget about all the HTML specific things and all the web specific things, because it had post handling and cookies and all the things that you need. All you need to do is write your business logic in a strictly typed, compiled language, like you're supposed to. Nobody agreed with me. Everybody wanted to just write their business logic in the templating system. And it was very discouraging to me for years that I couldn't convince anyone to write C code. But the web was growing so fast, exponentially, month to month it seemed, that there just were not enough C developers around. And many of the C developers thought the web was a fad, it was a toy, it was going to go away. This was not something worth spending their time on. And the people ended up tasked with building websites were not C developers, they weren't developers at all. Many of them were documentation folks that kind of got tricked into building the company's website. So eventually I had to sort of give in and say, okay, fine. Yes, I'll add loops to the templating system. I don't really see why you would need loops, but fine. Everyone's asking for loops. Function calls, local variables, recursion, like all this stuff slowly crept into the templating system over time because people kept asking for it. And eventually, and I refused to call PHP a language for the first 5 years of the life of PHP. It was a templating system and an API. But eventually I gave up and said, okay, fine. I'll give in and I'll try to make the templating system better so that you can actually write your business logic in the templating system. And then people started writing templating systems for the templating system. That one really got me. Like when I first saw Smarty, I wanted to kill Andre. But anyway, what I spent a lot of time on outside of the templating system, because I was still pretty skeptical about that, was the ecosystem around it. So however people chose to write their web applications, whether putting business logic in C or not, they still needed the ecosystem around it. They still needed a solid web server, and the integration between PHP and the web server had to be tight. They still needed an operating system that worked well with the whole thing. They still needed a tightly integrated database that was fast and memory efficient. And they had to host it somewhere. And back then, so the mid to late 90s, everyone was on a shared host. So you just had a very tiny slice of an Apache server usually, just a virtual host shared with hundreds of other people on the same one. And PHP worked very well for ISPs in that type of scenario because of the way, the architecture of it, how it hooked into Apache itself. There are these various stages of the request rec in Apache, and PHP just hooked into the content generation hook. Whereas other solutions at the time, like Mod Perl and a few others, they allowed the developer to hook into any stage of the request, including one called URL translation, which basically takes the request and maps it to a virtual host. But an ISP can't give you access to that, right? If you could take over other people's requests, then game over. That means you need your own Apache instance to run your stuff if you want to use this technology. If you want to use Mod Perl, you couldn't be on a shared host because Mod Perl was too powerful. And a few other solutions had the same problem. So strategically, they made a huge mistake by making the solution too powerful and giving people access to things that they really didn't need, which is why ISPs didn't implement this stuff. And everyone, all the ISPs say, hey, PHP is safe, we can use it. There are memory limits, CPU limits, doesn't give users too much power. For the most part, it's secure, they can't sort of cross the boundaries between virtual hosts. And we can offer this up for $5 a month for hundreds of people on a single server. So PHP won. And then when WordPress and other large solutions came out, they looked at what are people running, what are the technologies that we have available to base our solutions on, and they saw, well, PHP is everywhere. we'll use PHP. And things roll along like that. And PHP has influenced so many things over the years as well. My favorite one is databases, because I added the limit clause years ago to this old database. And I remember Monty asking me, hey, can you add MySQL support to PHP? It's like, yeah, you can, but what does your API look like? Don't worry about it. We cloned the mini SQL API that you already have support for. We cloned it, like function by function. You just have to do a search and replace in your editor, and you now have MySQL support. And he was right. I did a search and replace, compiled, and hey, I can talk to MySQL. Cool. But my queries didn't work because MySQL didn't support limit. It's like, hey, Monty, I have this limit thing. It's like, what the hell's limit? It's like, oh, I needed it because this database I was using didn't have cursors or anything, and I needed to not return me a gigabyte of data if I only want the first 10 results. It's like, okay, whatever. I can add that, he said. And like 10 minutes later, Monty adds limit to MySQL. and here we are. Like, 20 years later, everyone now, like, people just think, hey, limit is part of SQL, right? It's always been there. Like, it's not in the standard. It was a complete hack. It shouldn't have been there. But it's there and everyone's using it now, which I find pretty funny. But yeah, we later on, when the project became bigger, we spent a lot of time on the ecosystem and making sure that everything worked together and that we could scale up, but also more importantly, scale down and make it really, really accessible to new users coming to the language. And it's still that way. I mean, if you think about it a little bit, a simple problem like taking a static web page and you want to add one dynamic element to it, like say the time somewhere on the page. Like below the header, like below the title, maybe at the front, you want just a date stamp on this blog post that you have written in straight HTML. Seems like a simple problem. Add the current time. Think about how you might do that in Java, for the Java folks in here, or other languages as well. That is not an easy problem to solve in Java. I mean, what are you going to do? You're going to parse the HTML with some kind of XML parser and then find the right place to then insert some stuff? Are you going to use regexes? How are you going to take this existing text file of HTML and figure out the right place to add the time? It's going to take you a day or two to write the Java code that does that. How long does it take you in PHP to put the current time in an HTML file? As much time as it takes you to open up an editor and scroll down to the right place and paste in echo date, right? Save. And if you get it slightly wrong in PHP, if you get the arguments wrong or something, yeah, it'll not look quite correct maybe, the time might have the wrong format. The first 18 times you try your Java solution, you're going to get a stack trace this big. Null pointer exceptions, basically 20 messages on your screen saying you're stupid, you're stupid, you're stupid, you're stupid. And it is very, very demotivating, especially for newer developers, to have the language tell you that you're an idiot over and over again. PHP is very, very forgiving. It'll do something. Maybe not exactly what you wanted, but it'll do something. And it's not going to tell you you're stupid. It's not going to tell you you're an idiot. And it's motivating for people. And it's like, hey, that's not quite right. Let me figure out what I did wrong here and then make it do exactly what I wanted to. But it's very, very easy to get going. And I mean, PHP has the shortest hello world of any language ever, right? Open a text file, type hello world, save. That's a perfectly valid PHP script. You don't need PHP tags or echo or anything. There's no difference between opening up PHP tags, echo hello world, and running that versus just putting hello world in a text file, right? How long is a Java hello world? How do you even output stuff from Java, right? It's not trivial. Anyway, all right, enough of the past. So, current version coming out imminently. Few new things. Flexible here doc. Basically, this just means that you can indent your closing tag, and whatever this indent is will get subtracted from the output. So in this case, there won't be any spaces to the left of bar in your output, right? If you then put 2 spaces here, you'd have 2 spaces in the output. It just makes the code look a little nicer that you can indent your here doc statements in whatever syntax indentation you have in your file. We found some people sort of in the spirit of PHP running crap code really well. We saw people doing this. And what does this continue do? It's inside the switch, which is inside the while loop. Now, just sort of eyeballing, you would think, well, this would continue the loop. But it doesn't. It actually acts as a break in this case, because continue and break are similar in the way they act. And inside a case statement, it just becomes a break, which is probably not what the author meant. So this is now a warning. If you want to break here, use break. If you really want to continue the loop, use continue to. And that's what the warning now tells you. You can now use references in the list, both the longer form syntax and the short syntax version of lists. You couldn't do that before. You're now allowed trailing commas on the argument and function calls. In PHP 7.2, we basically allowed you to have trailing commas everywhere. Sort of our nod to JavaScript on the comma wars over the last couple of years. But we forgot function arguments, so basically we've patched that, and now you can also do it on arguments to functions. There's a new monotonic timer function. A monotonic timer is a timer that always moves forward and never stops, never goes backwards. If you're doing timing sensitive things that rely on, say, things like microtime to figure out how long did this block of code take, or you just do microtime to time various things, that depends on your system clock. So leap seconds, or even your NTPD, your network time protocol, if your clock is drifting, NTPD might actually slow down your clock a little bit or stop it for a bit to let it catch up. Or some admin might just change the time on you, right? And suddenly the time jumps backwards by 5 minutes. With a monotonic timer, that can't happen. It will always move forward. So if you do have timing sensitive code, you should use HR time and not microtime to measure things so that you don't suddenly get negative time. There's a new FPM status function, which is you can make some pretty cool dashboard pages and like Ganglia or whatever checks to check on what your PHP FPM processes are doing. So you get the overall for the pool. So this one is for the www pool, and it's currently serving a WordPress request, it looks like. And you get a few things on it. It's kind of like the status page that Apache has, for example, where you can see all the different processes. You now get that for FPM processes. There's new isCountable. There was a talk earlier today about how isCountable came to be. There you go. Basically, because we made count a little stricter in PHP 7.2, in PHP 7.2, count complains if you call things that are not countable, if you call count on things that are not countable. So we saw people ended up doing this to check, hey, am I allowed to count this? Is it an array, or does it extend or implement countable? If so, I can count it. That's a lot of template code to write for something so simple. So isCountable replaces that bit of code. A couple of new functions to get the first and last keys of an array. People be using like reset and end to move the array pointer around, and that doesn't always work well if you don't have an actual array in a variable. So this is a way of getting it on anything. The bigger thing internally in PHP 7.3 is that the DCE and SCCP stuff has been improved a lot. This may not say anything to you, these acronyms, but I'll explain them in a bit. So some other changes. We're using pCRE2 now instead of pCRE for the regex library. if you have a regex that breaks upgrading to 7.3, go have a look at the readmes and the various documentation on PCRE2. Chances are nothing will break on it, but I mean, we're upgrading a core component that does all regular expressions, and there is a slight chance that it could break some of your regular expressions. I haven't found any that break yet in my upgrades, but who knows. Get all headers is available now for FPM users, and a few other things. So yes, things that might break your code, PCRE2 could be. If you're using ODBC router or bird step, you're out of luck, they're gone. I doubt anyone in here even know what bird step is. Didn't think so. And various other deprecations. Please read the full upgrading doc here, PHP 7.3 upgrading. If you have any extensions written for PHP 7, you should read the upgrading internals. If you're still on PHP 5 and upgrading to 7.3, you have a lot of reading to do on the extension stuff. Because the extension API between 5 and 7 is completely different. So this won't tell you anything about that. You need to go read the 7.0 one first, then 7.1, 7.2, then 7.3 to get all the way here. All right. Performance-wise, 7.3 is looking pretty good. Nothing like the jump in 2015 for PHP 7, obviously. But still not bad. We still got a, I don't know, 10% boost here. And we're aiming to always go up from 7.0 to 7.1, there wasn't much of a change. There weren't too many performance changes in that one. 7.2 a little bit because Dimitri started optimizing and added new optimizing passes in the op cache. And now 7.3 with the better SCCP and DCE stuff, it's moved a bit more. 7.4 right now is looking a little slower because of type properties. I'll talk about that in a bit. But we're still hoping for some Dimitri magic to cancel out that performance hit. Latency-wise, obviously things have been improving as well, right? From 130 milliseconds to serve up the front page of WordPress in 2009, we're down to 38 milliseconds now on PHP 7.3. Even more important, the amount of memory from PHP 5.3, about 140 megabytes to serve up the front page of WordPress, down to 15. This is why PHP 7 is so much faster than PHP 5. The memory management is just so much better. And we don't copy things around as much as we did in PHP 5. That's where all the speed gains come from. So if you're still on PHP 5X of any kind, you're kind of lucky. Because if you're hosted like on AWS, like an earlier talk today said, they were hosting on AWS, your instances can shrink a hell of a lot. And you can turn off half your instances once you move to PHP 7. A reminder, we are releasing a new version of PHP every year. We have been for the past 4 or 5 years now. 4 years, I guess. That also means that our support for the various versions has shortened. So both PHP 7.0 and 5.6 are ending imminently, right? So if you're on anything older than PHP 7.1, you need to be planning to upgrade very soon. So 7.1, we're going to go into security fix mode only soon. So if you're going to upgrade today, obviously you go to 7.2. But since 7.3 is coming out very, very shortly, I would probably plan on going to 7.3 if you can. If that doesn't convince you, how about this argument? There are around 2 billion sites on the web, 10 million or so physical machines. PHP is approaching 50% of those. It might actually be higher, it's really hard to tell. And PHP 7 getting closer to 50% adoption. We're not quite there. We're probably in the low 40s still. But I don't feel like changing my slide every month. So, about 2.5 million physical servers are running PHP 7. But takes about 3,000 kilowatt hours per year. Costs about, in the US, about $400. Plus, then you pay for cooling, which basically doubles, and you spit out about half a kilo of CO2 per kilowatt hour. So at 50% adoption, we've saved about $2 billion in hosting cost over PHP 5, and a hell of a lot of CO2. But let's bring that all the way to 100%. It still pains me when I see like PHP 5.3 and PHP 5.4 running on large sites. There's really no excuse for that. Let's get everyone upgraded, please. And if you're still on PHP 5, you really need to do something. For everyone, for yourselves, for my kids, for your kids, for the whole world. Get off of PHP 5, please. All right. I promised you I would talk a little bit about DCE. So dead code elimination, DCE stands for SCCP, is sparse conditional constant propagation. And there's another term in there we use called escape analysis. Now, those are fancy optimization terms with all kinds of academic papers written on it, but it's really not that hard. So there's a trick where you can dump out the opcodes directly after the optimizer has run. So you can run PHP like this, can turn on all the optimization steps, just set it to -1, it's a bit field, turn on all the bits. And if you set the opcache op debug level to 0x 20,000 hex, and then run your script, you will get a dump of opcodes. So if we dump the opcodes after the optimizer of this little script, so here's a function that sets local variable a to 1 and returns 0. Obviously this assignment is completely useless, right? It doesn't do anything. PHP 7.1 will happily compile this file and create opcodes that assigns 1 to a and returns 0 for function fn. PHP 7.2 and 7.3 realize that, hey, this doesn't do anything. It does an escape analysis on it, and it says, hey, this cannot escape, it's a local variable, there are no side effects. We can safely delete these opcodes and not even put them in the opcode cache. So when you actually execute this script on the 7.2, the opcodes aren't even there. It's as if this wasn't even in your code. More complicated things. So the first 4 lines is just, these are actually no ops. These are just telling you where the incoming arguments ended up, which registers they're in. In PHP 7.1, you can see that this concatenation is done even though on the next line we overwrite it and then we return x. You can see the optimizer doesn't even create variable x. It knows that this function always returns 0 no matter what. So it compiles down to just a return 0. We can try to trick it. This is valid PHP, b equals a plus equals 3, but it figures it out that b is completely useless and it does the right thing. Now here is where PHP 7.3 has gotten a lot smarter than PHP 7.2. If you follow this through, you can see that all this ever does, it assigns a equals y and return a. This stuff up here is meaningless. PHP 7.1 or 7.2 couldn't figure that out. And there are more complicated things like this as well. So here we instantiate class A. Class A doesn't have a constructor or a destructor. We set a property on A, and then we return x. PHP 7.3 gets rid of all that crap. It doesn't even instantiate A, because it knows that there's absolutely no way that setting this property to $x on this object will do anything. Because there's no side effects, and this object goes away at the end of this function call, so there's no point even doing it. Right? So all this does is return $x. If, however, we added the structure, now there is a possibility of a side effect, because at the end of this method, the destructor is going to get run as A is destroyed, and this method might have some side effect. Now, it doesn't, but right now the optimizer only goes up one level and checks to see, is there a constructor or a destructor? It doesn't try to analyze whether the destructor does something that could have a side effect. Perhaps PHP 7.4 and later will go further up than just one level to check for escape analysis things. Then there's stuff like this. If you follow this through, we pass in x. So if x is true, we set a to this array. If it's false, we set a to this array. And then we return only the first element. The optimizer is smart enough to know that these are static arrays. We're only ever returning the first element. So this entire thing compiles down to just return 0. And this is getting to the point now where it's kind of, I don't know, judging you, right? It's saying, what the hell are you doing? You're writing all this stupid logic? This should just be a return 0. And I mean, if you write code like this, right, so here's a whole bunch of stuff, and the optimizer says, well, I'm just going to do echo 1, return 4, because that's all this code can ever do. So if you get a huge speed boost going to PHP 7.3, beyond like that 10% or so I showed you, I wouldn't brag too loudly about that. Just say, okay, whatever. My code is way faster. Thank you, PHP 7.3, but just don't brag about it on Twitter. You can if you want, of course, but we'll know. All right, some static analysis. There's a lot of static analysis at this conference. There's a PHP stand talk today as well. I started a static analysis project a while back called FAN, based on the PHP 7 AST. So PHP 7 has an AST built in as part of the compilation process. And you can hook in and you can pull out that AST. So an AST is an abstract syntax tree. It's basically this big tree of nodes that represent the code. And then a static analyzer can walk that tree and look at all those nodes and make sure that everything makes sense along the way. It's easy to install. You can compose or require it. Fan. You can have a little config file like this for a standard composer-like project where your source is in source and all your vendor stuff is in vendor. You can tell it only analyze stuff in source, load and bring symbols and stuff in from the other one, but don't give me errors on stuff in vendor. Only give me actual static analysis errors for my own code. And you can also set a target PHP version for your scan. Checks a whole bunch of things, typical static analysis stuff. So here's an example of some things you can do. So you can do PHP doc type annotations to enhance the built-in type system that PHP has. So PHP doesn't allow union types, for example. If you have a method that takes either a string or an integer, you can denote that with a PHP doc type here, and fan will check that this function is never called with something that's not a string or an integer. You can always also extend. Here in PHP you can say something is an array, but you can't say it's an array of integers. With fan you can, and you can also have like a union of different array types if you wanted to. So this says generic has to be an integer array. You can also have shaped arrays. And a shaped array, you actually tell it exactly what that array needs to be, what the array keys has to be. So for this to be a valid argument, it has to have keys mode and max. If those two keys don't exist in the passed-in array, then you'll get a static analysis error. And you can see the output here. We're 3 good calls, right? We're passing in a string, an integer array, and this has both mode and max. Or an integer array, mode and max, and this one as well. It doesn't matter the order of your keys, of course. But then here, I pass in an array to the first argument, and this is the fan error I'll get, saying, hey, this first argument is supposed to be either an int or a string, but you passed in an array. And then here I don't pass in the mode key in the array that I pass in, and I get a type mismatch again, saying, hey, this thing needs mode and max. So those are the types of things, and there are hundreds of things that fan checks. That's just a very, very short subset of it. I could do a whole workshop on fan. You can also write plugins. It comes with a whole bunch of default ones. If you really don't like $$ stuff in PHP, I don't know why you wouldn't. $$ is awesome. But if within your environment you don't want people to use $$, you can add the $$ plugin that will warn you if you start using $$ stuff. You can also have a printf checker, make sure that your printf tags match the arguments that you pass to it. Same with regex checkers, make sure all the regexes are valid. Like all of these things that you would only catch in runtime or in your unit test, assuming you have a unit test that covers that code, right? The whole point of static analysis is that it checks everything, even if there are some gaps in your unit testing. The static analysis might catch it. It's not completely foolproof. It'll never get 100%. PHP is very dynamic, and some of the super dynamic stuff, there's just no way you can catch via static analysis, but it will fill in some of the holes in your unit testing. We use it at Etsy. On every single deploy, the new commits have to pass through fan cleanly before anything can go out. And it catches a lot of stupid mistakes from people. There's also a daemon mode, which I think is pretty cool. So you can run the daemon, because it takes a little while. If your project is huge, it can take a minute or two to run static analysis over it. With the daemon mode, it has everything in memory, and you can get PHP Storm-like functionality in your VI, for example. So here, if I have a little function that says this takes an integer array, and I'm in VI obviously, if I then pass in something that's not an integer, so let's pass in a string in one of the array elements here, and I try to save the file. Right in VI it tells me, hey, you're passing in a string, and this thing takes an integer array. If I then go and fix it, and then write it, then the error is gone. So it's kind of nice that from within whatever text editor you want, you can add a little hook to do a static analysis before you save your files, or on the save itself. There's a little video in the talk. You can go look at the slides for some other things that you can do. So, there was an earlier talk about profiling. There's actually a brand new profiler that I bet very few of you know about, if any. It's called phpSpy. It's motivated by RBSpy, which is a Ruby spy implementation. The cool thing about it, it's very, very low overhead. You don't need any extensions. You don't need to compile with debugging flags. You don't need to do anything. If there's some PHP code running on your server, you can look at it and see what it's doing. You can also run it from the command line on new stuff, of course. So just to show how it works, you set the sampling interval, which by default is very, very short, like 2 milliseconds or something. But to illustrate how it works, I set it to 200 milliseconds. This is in nanoseconds, so it's a big number. And I'm doing a sleep 1, so this sleeps for 1 second. So what it does is it checks, hey, what are you doing right now? Every 200 milliseconds, and it gets a stack trace. And obviously this is just a sleep call off of main, so the stack trace is pretty short. But you can see that there are 5 of them, because every 200 milliseconds over a single second, it's going to happen 5 times, right? So we get 5 stack traces saying we're in sleep right now. That's not super exciting. We can also phpSpy any running PHP process. So in PHP FPM process or Apache process, anything, we can phpSpy it, and we can get the current stack trace of what's happening. And it's going to print out a whole ton of them, because it checks every couple of milliseconds by default. And you can set that frequency, of course. So here, it's obviously running WordPress, and I'm getting a bunch of stack traces from WordPress when I go in here. Still, how useful are all these stack traces? These are hard to read. How do I get anything out of them? It comes with a couple of scripts called Stack Collapse and Flame Graph. And when you run the output through those 2 scripts, you get something that looks like this. So this is me running phpSpy on a fan run. Well, this is fan analyzing itself, actually. So we get an idea of what fan is actually doing, and we can like zoom in and we can look at this particular thing, and then we can see what this is calling and how much time is spent in these various things. Now, at Etsy, we have found PHP Spy amazingly useful to figure out why things are not working the way they should. We have a bunch of cron jobs, for example. We have Gearman jobs that run for a long time. And occasionally they get stuck. And it's hard, or maybe they don't get stuck, maybe they're just running a really long time. Sometimes it's really hard to know, why is this thing not finishing? And running PHP Spy on it, sometimes it's extremely obvious to see this thing has gotten into a loop. And you see on the flame graph, you see like 2 towers, right? It's spending all this time in these 2 sections, basically going back and forth, just here. Or you just see one big tower where you're stuck in some kind of MySQL request that's taking forever. And it's a very, very useful way of debugging running PHP stuff, because you can attach it to existing PHP. PHP Spy itself is pretty magical. You have to compile it for the version of PHP that you want to spy on, and it can do all this without any sort of debugging symbols or anything, because the code itself looks like this. It has hard-coded offsets, so it knows where all the different, like the executor globals, live at plus 488 in PHP 7.3, right? These numbers are going to change for other versions. So it has all these magical offsets and paddings and things where it can go in and it can inspect the memory and pull out useful information, even without debugging symbols and extensions or anything. So it's kind of a really, really cool tool, because it doesn't depend on any sort of pre-thought on your part. If you're going to profile something with any other profiler, you have to load the profiler, load the extension, and actually sit down to profile. This is sort of an after-the-fact thing that you can go back and check things with. How am I doing? Okay. All right, I'm running out of time. So, PHP 7.4. We don't have a whole lot for it yet. The big one that's been accepted is type properties. I mentioned earlier, it does slow down PHP a little bit. There's not much to type properties, right? It's simply you can put types on your properties. I wouldn't suggest doing a for loop and having this I plus plus as your counter in the for loop. That's going to slow down a hell of a lot in PHP 7.4. People don't do that, right? And that's why we don't put types on every variable, because normal variables are written to a hell of a lot. Properties don't tend to get written to that often. But still, if you have a lot of properties and you keep writing to them, you're going to see a bit of a performance hit in PHP 7.4. Hopefully we can address that. A really interesting new feature that's likely coming in 7.4 is opcache preloading. And opcache preloading works by you pointing, you point your preload, your opcache preloader to a script. That script will go through and load the files that you want preloaded into the cache. This happens on server startup. So right when the server starts up, before it forks any FPM process or Apache processes, it's going to load these classes into the opcode cache, and it's going to register the classes with PHP. So there are kind of 2 stages to this. A normal opcode cached script gets cached into the opcode cache. Then on every request, we figure out, do we need this class or not? If we need it, we will register it and initialize it for that particular request. Normal caching speeds up the compile time, but it doesn't prevent the slight performance hit of initializing the class per request. Preloading speeds up both of them. So you basically have, as if it's an internal class in PHP, like it's an extension, but it's written in PHP, it can get preloaded, it'll always be available. It does mean that if you want to change it, you have to restart the server to reload it into PHP. And you can see here, without any sort of preloading, in this case I'm just doing a new A. I have an autoloader that autoloads a missing class. You can see the autoloader gets called for A on my new A thing here, and A gets spit out by the constructor. Now in the preloaded case, So I have this little preload function that I register. I say, hey, upcache preload, use this script, and I'm preloading my a.php file, which ends up getting compiled here, upcache compile file. When I then run that, you can see that the preloading means that the autoloader was never executed. This autoloader that ran here, in this case, never gets triggered because A is just built in to PHP itself in this case. Now, this becomes extremely cool, especially when we get a JIT, because if you can get JITted preloaded things, you can essentially write extensions in PHP that are almost as fast as writing that same extension in C. And it's going to be, it depends on what you're doing, of course, but the performance hit of doing stuff in PHP at that point is going to be pretty small. I can see people writing string classes, for example, saying, okay, I'm going to have a string class, I'm going to change all the argument orders, all the things you guys complain about sometimes. I'm going to preload the string class that fixes all that, and you're not going to have a performance hit for doing that. And I think that's pretty exciting. So, I'm out of time, but maybe I have time for a question or two, hopefully. That's the most interesting part of it for me, at least. This thing works. Yeah.
Talking about the documentation of PHP, why do you still keeping documentation in SVN, and why don't we migrate that to Git and expose to GitHub? I actually started to look around on the internals list. I want to work on that, but I don't know if I should or shouldn't, so that's a question.
Yeah, the reason it's still in SVN is that we have a lot of people that are used to SVN working on documentation. A lot of these folks are not super technical, and if you want to teach them all Git, I mean, we need to move it to Git, but that has been the stumbling block of having all these folks that are currently productive and then taking away their SVN that they've been used to for the last 15 years and saying, you're now using this Git thing. Oh. And I can just hear the screams, right? For non-developers, I mean, as developers, we've all gone through that pain of learning Git. For non-developers learning Git, it's hard.
But might be an idea for the future to migrate to the documentation to GitHub. Might be an idea for the future.
Yeah. Yeah, I mean, we need to do it, but none of us have had the sort of the motivation or the energy to attack that yet. Okay.
So, regarding the new versions, do you see generics coming into nearest future into the language, or at least typed arrays?
So you're saying, I mean, I think I answered the typed regular variables part, right? For performance, I mean, it would be trivial to put types on everything. It's not a technical challenge, but your PHP is going to slow down by a factor of 2 or 3. Same with typed arrays. When do you stop checking the type? I mean, if you have an array with 1 million elements and you add the 1,000,000th first, you're going to be sitting there for 500 milliseconds checking that array. It's just not feasible. This is this kind of stuff you need to do at static analysis time. You don't want at runtime, every single time you run your code, you have to scan every single array and make sure that every element in every array is the right type. From a performance perspective, it's just death. You can't do it. So no, that's why we don't do it. It's strictly performance. It's not because it's hard to implement. We can implement anything, but we have to balance performance and features like that.
One question. When you predict that you will strict type the throwing errors on the methods?
Sorry, strict type errors?
Well, currently we can write the quotes and the type of the return variable. And what about throwing errors? Because currently we can only doc type that the methods can return, can throw an errors, and
Oh, I see what you mean. So if you're throwing the wrong thing or something,
yeah.
yeah, we could probably check that. I'm not sure how hard it would be to implement. At static analysis level, these checks are done. You can catch this with static analysis. I'm actually not sure why we don't do that one in the engine, because I think performance-wise that should be okay. You can put in a feature request and see. Maybe there is a good explanation for it that I can't think of right now. But no,
I will try it.
That should be safe. Others? I think I have like 2 more minutes. There's a hand way back there. Can you? Okay.
So, following the generics question, I guess something like that would be possible with just-in-time compilation, is that right?
Inline compilation?
Just-in-time compilation, JIT.
Yeah, so, I mean, you still can't do this at JIT time. Like, even with a JIT, you're still going to be adding things to arrays at runtime, right? The checks still have to be at runtime after compilation, unless it's a static array. Okay, for static arrays, yes, you could do it. Most arrays aren't that static. Most arrays change. But yes, for the immutable read-only arrays, yes, you could do it with a JIT thing.
Well, I mean, there are generics in Hack, so
Yes.
and Hack has basically the same syntax as PHP, and
But the generics are not checked at runtime. So that's the confusion that a lot of people have. Because the static analysis step is very well integrated into Hack, you can completely get around generics in Hack by just ignoring the warnings from the static analyzer, and in runtime it won't check. For the same reason, it's too expensive.
yeah, I know. But is it possible to move PHP in that direction too?
Well, we have that. Our static analyzers are just more separated. There is no generics in Hack. It looks like there is, but there isn't. The syntax is there, but it doesn't check. So yes, we could do that, but why? It makes no sense to have runtime syntax that isn't checked at runtime. That's my point. The Hack syntax is only for the static analyzer. It doesn't get checked at runtime. And that's the thing that a lot of people are confused about with Hack. That there are many pieces of Hack where the syntax is there, but the check is not. So, and I get that question a lot, and people go, oh crap. Everyone thinks that because the syntax is part of the language checks. It doesn't. It's just like a PHP doc thing that's been moved outside the PHP doc without the check. So, and that's not a direction that I like for PHP. If the syntax is in the language, the check should be in the language as well. Yeah.
Okay. I don't know if I understood correctly, but you said that there will be type of properties in class in PHP 7.4,
Yes.
but it can lower performance?
Yes.
But why?
Why? Oh, I lost my slide. I think that's pretty obvious why. I mean, because now we have to do a type check. Every time you write to a property, we have to check that the thing you're writing is the right type.
Okay, so if it's not necessary to use type, it's better to leave it.
Well, I mean, so many people have been asking for type properties. They probably want types on their property. But yes, it's going to be a performance hit for everyone, because we have to check if there's a type on it. If there's a type on it, then check the type. So even if you don't use a type on your properties, you're still going to have a performance hit from this feature. And there's no way around that.
So it connects with function arguments too?
Sure, but
Yeah.
with function arguments, it's only on, I mean, with variables, you tend to be able to write to those variables a hell of a lot. With functions, you tend to call them, well, you also call functions more than once, but within a method, for example, you might write to a property many times. So, but yes, any sort of type, any type check at runtime adds overhead.
Thank you.
There's no way around that. That's what a type check is. It's extra checking.
A little bit off-topic question, but how many elephants do you have?
I don't even know. I give them away. I get a lot of them. I might have like 6 or 7 at home, I think. I've received many more over the years, but I tend to give them away to folks. Way over there by the wall, if you can throw that far. Whoa.
What's your opinion on async stuff? Do you see a place for it in PHP core?
Yeah, there's some work on fiber type approach, which is sort of lightweight threading and async work. You have to be careful that, I mean, yes, async definitely. Anything we can async, we should. But there are also things that are very, very hard to get right without full-on threading. And I don't see us ever getting full-on threading in PHP. Something like fibers and generators and things that can solve like 95% of the problems are definitely things that we're working on and looking at. And I don't see fibers coming before PHP 8, if that. But there's definitely folks looking at that now.
Cool.
Oh, right. Please, how about covariance and contravariance by the argument list? I mean, I cannot declare a function in the interface which by I pass a return time type.
Yeah.
Okay, whatever.
That's a bit of a religious argument, but yeah, I have registered your feature request.
Sorry. Okay.
I think we're out of time. The next talks is supposed to be starting, so thank you very much, folks.